Pre-Cal 12. This is Coach Jay speaking. The end of a day on a Friday. Hope you're having a fantastic day where you're at. That's not mine. There we are. We're talking about unit circles right now, so hopefully you can get it and go from there. All right? Awesome. Let's do it. All right, unit circles. Let's talk about that. Why is it important?
Because
Yes.
Poetic.
All right, be honest with me. We're going to be real right now. How many of you have done the unit circle and have had no idea why you've done the unit circle? Okay? All right, fair. I'm going to give you the why, okay? I'm going to give you the why. I shoot straight. Here's the deal. I understand this right here. A lot of you will go into your field, whatever it may be, and a lot of you will never use this again. I'm being real with you. I will tell you, though, the reason why we have to do it, though, is because of the fact that it is on the college placement exam, number one. And number two, in college, you got to know it if you take a math class. So those two things, if you go into engineering, obviously, or something of higher math, you will go in more into it. But I'm just telling you, as far as for your sake, it's just setting you up for college there, okay? Here's the thing. We will have to memorize this one time. That's not the main purpose. I want you to know how to apply it. So that's kind of where we're headed, and that's where we're at, okay? So here's what I want you to do. With someone next to you real quick, I'm going to hand out the quizzes that y'all took. While I'm doing that, I want you to, this sounds like very monotonous, but I need you to engage your mind on the unit circle just to remember it. The blank one, I want you to fill this out, okay? And amongst each other, I want you to come up with some ways that helps you to kind of remember it. I'm going to set a timer for about 4 minutes. You're going to do as much as you can, about 4 or 5 minutes, and then we'll touch base and go from there. Sound good? Cool. I'll hand out the quizzes while we do that, all right? Go right ahead. Go. Let's see, where's my hat?
I just memorized like every single year of high school, so by now.
No, hopefully by now we got it, right?
Mr. Johnson, Coach Johnson.
Yeah, what's up?
My friend gets out here over all the time.
The quiz, you want me to
I'm going to hand them out and talk about it. So as long as you're, would you mind doing this one? Just this first part, stay over here while they get this out. Once they put them away, you're good. There's different versions, but at the same time, I don't want to. Just for the integrity. Cool. Got that there?
And then on this side,
Josh. You left it up there. As you fill that out, if you have questions on your quiz, let me know.
Oh yeah.
Obviously, there's not too many questions, right? Only two that I think you really yes, I'll do those two. Just that concept. That's it. We need to. We can touch base on that too.
Little things. Thank you. You're welcome. I do this. The first one is 1, 2, 3. Y'all are partners? Yes. Oh, that's it. Mine is one full French. I don't know how to spell mine. It just actually makes me seem really possessive.
Sorry, I didn't mean to throw that. It's like bam, bam.
Thank you.
You're good now?
Yes, sir.
This last year class is
Don't be
hard.
afraid to ask. Don't be afraid to ask. The whole day is just
Slow. Well, you got one thing on your mind. Interesting.
Oh yeah, I was wrong.
And I keep coming at you, I'm sorry. I gotta hand them out now, otherwise I'll forget.
That's not true. Coach, can you say coach? I know he hates us.
How you inspired?
just came in here today because I missed yesterday. This is my study hall period, so
It's your study hall period?
I'm in the class here
Since when?
today.
Thomas, you
Yeah,
good?
that's a good thing.
You're good.
Good question.
All right, hey, as you're filling that out, I'd like to do this. Did everyone get this, by the way, the calendar? Everybody write on this? Everybody not? Okay, so I just want you to put your birthday down so we can recognize that, okay? So if you could just put it down, and that way I can hopefully do that there, okay?
That's Kobe's birthday.
There you go. Pretty cool. All right, so let's do this here. As we get started, here's what I need. I need some help. I know that, and I heard a couple people say it. We've done this for almost every year in high school, other than probably geometry. That you've had to know this. So I get that, man. This is kind of like, man, another thing. But again, we're going more into application. So we're going to hit this expecting that you've already kind of done this before. But at the same time, I want to make sure we kind of share some strategies. So real quick, here's what I want to do. We'll give some tickets out for some really good ideas. I want someone to help me with how you determine the angles in terms of degrees. Do you have any ways that you kind of approach that, Emma?
Yeah, so like from the 0 to 30, obviously there's a 30 degree difference, and there's 15, 15, and 30.
Yeah, so you kind of start and go add 30, right? Then you add 15, and then add 30. Do you do anything else from there? That's exactly right. Yeah, it's just the same pattern. Do you see it? So 30, 15, 15, 30, and you just keep going, okay? Usually the degrees isn't the bad part. Usually people get that pretty easy. So again, that would be more or less the degrees. Questions or any other thoughts on how you found degrees or have used that before? Cool. What about probably the toughest part, or one of two things that are tough for people, the pi in terms of radians. How do you remember that? Sophia, you got something?
What I do is that, okay, you do like, you start going this way, and on the bottom you do 3, 4, 6, 6, 4, 3, 3, 4, 6, 6, 4, 3. And you just kind of like remember the pattern because like it's whatever number it ends on, like it starts back up. That makes sense?
Yeah.
And then for the top, I do like the top right, it's just like pi, so that's easy to remember.
Yeah, that's good.
And then the top left, you do minus 1 of whatever number is on the bottom.
I like that. Good. I'm just taking notes for just so we have it.
And then the bottom left, you do like minus 1 of whatever's on the bottom, or plus 1 of whatever's on the bottom.
Good. Nice. And?
And then on the last one, you go up to like the top left, and you look at the two numbers and you add them together.
Ooh. Say that one more time. I've never heard this one. Go ahead.
You do the two numbers on top, so where it says like 2 pi over 3, you do 3 plus 2.
Yeah.
And then you get 5 pi right there on the plate. Do you see where it says?
Wow, I've never seen that before. This is why y'all are awesome at that. Does that make sense? So if you look at this one, it comes straight across. The one that goes straight across there is 2 plus 3 is 5, 5 pi over 3. Same thing with 3, 4, and 5 and 6. That's pretty good right there. I like it. Good. Any other thoughts on the radians there? You got something, Thomas?
On the bottom right,
Yeah.
you take the denominator and multiply it by 2 and subtract 1.
Yeah, so you denominator, multiply by 2, and subtract 1. If you do that, you would get to the top side as well. I like that. I've heard that one too. Any other thoughts? Any other questions? Or any other ideas there? Good, good. Okay, how about the outside, the points? First off, is everyone good with 0, -1, 1, 0, 0, 1, and -1, 0? Y'all Gucci on that? Isn't that what y'all say nowadays? Yeah? Some of you look at me like I'm crazy. Okay, so we're good on those. What about the actual points themselves?
That's your phone.
They are mine.
Oh,
I've been looking for it for the
Oh,
last
okay, I was like-
little bit. Yeah, yeah.
you gotta I cleared it though.
I got a text. Did
Yeah.
you read it?
No, I didn't read it. I cleared it.
You better not. No, I'm just messing. Good. Thanks, Diego. Appreciate it. Does that deserve a ticket?
Yes.
Yeah, I've been looking for it. I couldn't find it. Good. All right. Point wise, tell me how do we remember that? Other than 1, 0, -1, 0, and all that, how do I remember that? Square root of 3, 2, 1/2. How do I remember this stuff up here?
If you memorize the first right quadrant, you can solve it.
Ooh, I like that. Yeah, so Josh said, if I can get this first one here, I pretty much have a good idea. It's just the same thing mirrored over, right? With the different negatives. Why are these values negative here?
Because cosine's negative.
You actually took it further. Yeah, cosine's negative there, right? In fact, what's positive over here?
Both of them.
All, right? You remember this? All.
Students take it.
Sine's positive here, right? All students. What's down here? Yep, so this is tangent, which is take, and then this one is cosine, which is what's positive over here, right? Okay, we'll talk about that a little bit more. Diego?
I don't understand that.
Yeah, it's a great question because it's usually something that kind of incorporates it here. All means that everything's positive. You probably can see that here. Sine means that sine's positive. That's the kicker. Sine relates to what?
X. Or Y.
Y. Good. Sine is always Y. Okay? So when you think about that, that's something big. We'll talk about that in a second, kind of put in a nice little chart for you. But sine is always Y. What's cosine? Cosine's X. Therefore, if you look at it, the X's are positive, right? So instead of cosine, you could also say X down here. This would be Y's are positive. And then tangent is what?
Both negative.
Yeah, so it's Y over X, right? Y over X. That would be the value we're looking for there. Okay? Cool? Someone said today, which I really do not appreciate, all short teachers care. I did not appreciate that. It was a little subtle dig right there on a Friday. I was having a good Friday until they said that. So I bankrupted their tickets. I did. I really did. Okay? All right, but no, whatever it takes, all I almost said students. All students take calculus or all short teachers care. Just make sure you understand which is positive, okay? Also, I don't know, anybody else have an idea on the points? We're going to go to something different here in a second. Points there?
Memorize the first ones and then
Go from there? Yeah. Do you notice that they're all over 2?
Yeah.
Okay, if you know that, that's the first part. Put them all over 2. You got something there?
Yeah.
Come on.
So
Teach. Let's go.
good job,
Teach.
Josh.
so
This feels pretty good.
so I kind of follow the line. So if you memorize the first quadrant, then it's easy from there. If you know all students take calculus, so I just pretty much follow the line all the way down to this side, and that's these exact same points. You just gotta get the negatives and positives, and then so here it pretty much mirrors over. So that's the same, that's the same, that's the same. And then once you get here, it mirrors there also. So the middle, 45 and 225. And then once you get these, it's pretty much the exact same thing. Just goes you just follow the line across. The exact same points, you just gotta get the positive and negative.
Wow. Give him a hand. Nicely done. Teacher right here. Most likely to be a GAC when he graduates. Isn't that right? I like it. I like it.
I think so.
All right, so, Thomas, you got something?
If you have
Come on.
trouble with the positive and negative, just think of that being in the middle of a graph.
Okay. So this right here,
Yeah, that's 0, 0.
0, 0, and then so if I go left, I'm going negative. That's actually money. Going down, that's negative on the Y. So just think of it like that. You're good. Emma, you got something?
Also, the whole graph thing, if you look at the numerators, since root 3, that's a bigger number, it's at higher distance. You know what I mean?
No, that makes sense. No, that's good. Yes.
I don't know.
I'm good with that, absolutely. No, and here's the thing. I want you to look up here. Why did we give multiple ways to think about this? Because I understand. Here's the thing. If I just told you how to learn it, then it probably wouldn't connect. But maybe the way that Emmett connects it would be different than the way that Josh connects it or I connect it, okay? So my big thing is just get it down, okay? Get it down. We're going to memorize this one time, but again, we're going to really focus on the application. Now, I know we're on a Friday right now. I 100% understand that. And I get the fact that right now we're just like, we're ready to go. Here's what I'm going to tell you, okay, to hopefully help you get paced here. I'm going to go over this together, right here, this whole thing together, and then afterwards we're going to collaborate and we're going to be out of here sooner than we can even snap our fingers at. So we're going to look at just the top part. This is really important for what we just talked about with what Diego asked, and I want to make sure we understand this, okay? So I want you to, just on either the back or the front of that unit circle, get this down, because some of you either, maybe some of you dominated this, but I think that based on how I remember teaching Algebra 3, some of you struggled with this. And I want to make sure that I also go through this together, okay? All right, sounds good? Got it, Kennedy? Mm-hmm. She's taking a picture. I just want to make sure, okay? All right, sine. What about sine? What's the ratio? The ratio, SOHCAHTOA, right? So what would be sine? Opposite over? Hypotenuse, right? So, SOH, right? What about cosine? Adjacent over hypotenuse. Good, Graham. What about tangent? Opposite over adjacent. Yeah, there we go. Right? Now, the secant, cosecant, and cotangent are a little tricky. They're a little different, right? Secant goes with what? Cosine. Does anyone know of a way that they remember that? Because some people forget that. All right.
The SEC is on the coast.
Oh, that might be pretty good. That might be pretty good there. Mary Grace, do you have something too? You just have it.
The last letter of secant is the first letter of cosine.
Ooh, the last letter of secant is the first letter of cosine.
And same like vice versa too.
That's pretty good. Yeah, I like that. Oh, like they go back and forth between each other. It's really good. I like that too, Thomas. I wasn't ignoring you. I know Mary Grace had her hand up. But what Thomas was saying was pretty good. The SEC is on the coast, right? It's also the worst conference, but we're not going there. The SEC is on the coast, all right? If you remember that, that might be good too, all right? No rise out of that? I know. All right, so SEC and cosine go together, so it's the reciprocal of it, right? Say reciprocal. Say reciprocal. It's the flip version, right? So what would this be? Yeah, y'all are rocking. Cosecant would be? What would cosecant go with?
Sine.
Yeah, that's right. So it's like S and C, right? They kind of go together. Cosecant goes with sine, which would be? H over O. And cotangent is? A over O. Very good. This is with our triangle stuff. Got me? If you remember that, that's the triangle stuff. We're going to live in a different world, though, okay? We're going to go over to this unit circle side. And it still involves this, but we're not going to go into necessarily the in-depth why about it, but just understand that sine corresponds with what on the unit circle? We kind of said it already, right? The y, right? Good. Nice. Cosine is? X. Good, Graham. Tangent is? Y over X. Good. Do you remember sine over cosine too? That's money as well. What's secant? What would secant be?
Y.
Tell you what, right now I'll give 3 tickets to someone who can tell me. Stand up and boldly tell me what secant would be for the unit circle.
1 over X.
1 over X is exactly right. Nicely done. Good. Thomas, I've been kind of taking it away from you, so my fault on that. You go with cosecant. What would cosecant be? So this is 1 over X, right? 1 over Y. Good. So cosecant would be 1 over Y. Okay? Someone else that has not gotten a ticket yet today, tell me, boldly stand up, tell me, what would cotangent be?
X over Y.
X over Y. Nicely done. Nicely done. Good work. Okay? Now, question, real quick. Are there any questions over that up there? Are we good? Okay, here's the thing. I need you to really dial in, okay? I need you to really dial in. The next 4 that I'm giving you, I've tried to give you the 4 toughest ones that I could think of. Gradually developing. So the first one's easy, second one's a little bit, and then it gets tougher and tougher, okay? How many of you have seen this and struggled with this in the past? Ish. Okay, someone maybe. Maybe not. That's perfect. So here's what we're going to look at here. There's 2 things that we want to focus on. Number 1, where's the location? Number 2, what's the value? Number 1, where's the location? Number 2, where's the value? Chantel, got a question for you. Sine of 2 pi over 3, right? Where's the location? Like, what angle are we looking at? Yeah, over here, right? Where would 2 pi over 3 be? Yeah, you're exactly right. Chantel's exactly right. So that's the focus we're looking at. We're looking at this up here. Got me? Right? So what if I said the cosine of that? What would you say, Zaria? What's the cosine of that part? -1 half, right? That's the x of it. Good. But it doesn't say that. I said sine, right? So someone else help me. What would be the sine of that? Ty, what's the sine of that?
Root 3 over 2.
Nicely done. Root 3 over 2. You're rocking. So it would be the y there. This would be root 3 over 2. Good stuff. Okay, now let's look at the next one. That one's pretty basic. This is where it gets tougher. Okay? You ready for this? Where's the location? Now, before we go any further, the first question is where's the location every time? If we can find that, that's half the battle. So we find out where the location is at -2 pi over 3. All right, Diego, you ready for this? I'm going to kind of put you on the spot here. The positive version of 2 pi over 3 we already found, right? Where's the negative part of that? That might be a little tougher.
Is it across from it?
Good thoughts, not across from it. This would be the positive version, right? What happens when it's negative again? Where do we go?
Oh, so it was
So where would I stop?
240.
There you go. Yeah. Kennedy and Diego, you're right. That would be 240 there. That's the location. Got me? That's the location. Anybody not get that? All right. We're almost there. Now we've got this mess right here that we've got to deal with. What does cosecant focus with?
X.
1 over y, isn't it? Right? So we take 1 over y. And we know that what is y?
Y is -1/2.
Y is -1/2. Negative square root of 3 over 2, right? So what we're going to do here is we're going to take 1 and divide it by negative square root of 3 over 2. What do we do with it? How do we simplify? Here's a hint. You ready? What do? We gotta flip it. I'm not coming down until someone tells me the answer. I'm gonna pass out.
No one talk.
Woo! I'm a little lightheaded. Did that surprise you?
Yes.
Good.
No.
Good. No, it didn't. I was gonna do a push-up, but I didn't want to show anybody up. You know what I mean? All right. So what does that turn into? My face red because I feel lightheaded.
It's okay now.
It's good. 2 over root 3, right? You got it? What do I do to get that square root out?
Multiply by
root 3.
Yeah. And that, what does that turn into?
Root 3.
-2 root 3 over?
3.
Yeah, good job, Graham.
I like
-2
that,
root
Graham.
3 over 3. Got it? How many thought that was tough? A little bit? I'm seeing some nodding. Okay.
At least you practice.
I think it's just reps. I agree, Diego. Just reps. So again, the location, and then we got to find what is the unit circle, what is that ratio that we've got there, and then execute it from that location. Okay? Let's go 2 more. We're going to go a little bit quicker here. Negative pi. Elijah, what direction am I going with negative again? Yeah, back like the clockwise, right? Good. And when I do that, where am I going to land if it's negative pi? Kind of a trick question because it's kind of... Yeah, it's kind of like if I go 0 to negative pi, right? I'm going negative 180. It kind of is, it's because it's the same. It'd be on that pi or 180 side. Do y'all see that? Because pi is 180, right? If I go negative, it's because it's halfway in between. it would be right here. So our location is here, right?
Mhm.
And tangents, what ratio, real quick? Y over x, good Josh. So if I do y over x, what would that be? Hold up, sorry about that. Did I just delete that? Look at that. Let me see. There we are. Yeah, y over x. It'd be 0 over -1, which would be? 0. Good. Does anyone struggle with undefined or 0, like when to use that? When it's zeros on the bottom, it's undefined. You know how I remember that? If it's okay, zeros on the top, we're okay. If it's 0 on the bottom, we're no. Can't have that. That's undefined. So do you see that? See that there? So I remember it that way. So that means this would be 0 for our tangent side, okay? All right, here we go. The last one where we're doing it together, and it just so happens that it is the toughest one, okay? So let's see if we can kind of help each other out. First thing, cotangent of -20 pi over 6. I really want you to get this one down, okay? Graham, you want to help us just kind of that first step. What would you do?
Subtract 2 pi until it gets to something that's on the inner circle.
Ooh, so -20 pi over 6.
Or add.
That's a pretty big one, isn't it? So we want to add to that 2 pi, right, Thomas?
Divide it by 2 to make it small.
Now, good thought. I don't know if I want to divide it by 2 because I don't know if I hear what you're saying, get it smaller. I don't know if that's going to get us the same spot every time. Sometimes it might, but maybe not in this case. I would say let's do the 360, right? So where we come, right, we keep going as many times as possible till we come back to the terminal side or a coterminal side, right? So what could I do with -20 pi over 6? Add what? 2 pi. Good.
Wait, why 2 pi?
Yeah, good question. So -20 pi over 6 is a big angle, right? So what happened is it's already gone backwards because it's negative a couple times. So what we want to do is just take it and just kind of find something that's more simple. So I'm just rotating around and just seeing where we land, okay? So what can I do with this to simplify?
You gotta find common denominator.
Common denominators by simplifying. Put a 6 on the bottom, multiply the top to get 12. What does that equal?
-8 pi over 6.
Good, -8 pi over 6. Now, this is okay. I could still do this. If I wanted a positive value, what could I do again?
Do it again.
Just add 2 pi again. Just do it one more time, right? I like that better because I can see positives better there. But I would just add this same thing again. So add 12 pi over 6 to get,
4 pi.
good, Red? Yeah, 4 pi over 6, what does that reduce, Red?
Oh, 2 pi over 3.
Nice, yeah, that's right. Good. So my location is where? That's the toughest part, I think. Where's that? Where's the location?
120.
120, good. Good. And what is cosecant linked to, or cotangent linked to? Tangent, and specifically x over y, right? Okay. Almost done. Let's finish strong. Y'all are rocking. What is the x here?
-1 over 2.
Good, Kevin. -1/2. And what's the y? Root 3 over 2. Nice. How do I simplify?
Cancel the 2's.
You could, absolutely. Some people do that. That's perfect. Just to show why that's the case, you could flip it to the top, right? And multiply by 2 over root 3. And what cancels?
2.
2's. And now we've got -1 over root 3. And what do I do now? We don't like a square root in the bottom. And what we do is turn that into square root of 3 over 3 with a negative. Having a square root in the bottom is like an Ohio State fan class. You know what I mean? It's like that.
Get it?
All right, negative square root of 3 over 3. Good stuff. Sorry, Mary Grace. Sorry.
Easy.
That would be it. Ryan was giving me junk today, so I have to. All right, questions on that? Cool. Hey, listen. If you right now, sometimes I'll do this on a scale of 1 to 10. 1 being like I really don't get it, coach. 10 being like I get it. I think I'm dominating this. I want you to put yourself on a scale of 1 to 10 from what we just talked about, right? Because we went through that pretty quick. And I want you to just show me real quick. I'm not going to point you out. This just helps me. Cool? Show me right now on your hand. Cool. Good,
Shane
good,
got vote.
good. Got you.
Shane
Got
got
you.
vote.
That's good. That just helps me to identify where we're at. So I saw a lot of 7s, saw a couple 4s, a couple 6s. That helps me to identify that I'm going to come around and make sure I help you out, okay? All right, so here we go. This is going to be our next thing. We're going to go into a little bit of a contest with you and a partner, okay? So here's how this is going to work. Do we know where the unit circles are? Are they? Did I take them? I think I got them over here. Yep. Perfect. Okay, I'm going to give you a unit circle. I want everyone to put everything away, okay? Everything away. Join forces with you and 2 other people. Cool. If you got your table, that's fine. Or if you have a group of 2, that's fine.
I don't know
Okay. Here's what I want you to do, okay? I want you to fill out the second quadrant. That's it, just the second in your group. I also want you to, and I'm going to take out a couple of these. I want you to do 3 of these, and I'll kind of put them up here, the ones that I want. If you finish before the bell rings, I've got something for you. Got me? It benefits you there,
Will it
okay?
help your grade? Is it money?
Maybe.
Is it money?
Could be money. Yes, lots of money. Ready?
1,000 tickets.
Let's go. Here we go. Get it there.
So all of these are just gonna be the second quadrant.
Those right there.
So this is what
They may not, and you might have to help with it. Do this. Go unit circle, then I'll flash up the one with all of them. Is that cool?
Well, you know what?
Fill out the unit circle.
I got
Oh, this is 150. Yeah, 135. Okay, so that's